Hello, my name is Kathleen Quinlan. I'm going to talk to you today about what interests students and why, how lecturers can motivate and engage students. So first, what is interest? I rely on Renninger and Heady's model of interest development for the research I'm reporting to you on today. This developmental theory defines interest as a tendency or desire to engage with some object or content, such as chemistry or physics. Interest has cognitive, emotional, and motivational dimensions. It also has been shown to have a connection to the physiological and neurological reward circuitry in the brain. And basically what this means is that it is rewarding to engage with something that's interesting. For teachers, this theory is particularly useful because it emphasizes how interest can grow through supportive interaction between a student and his or her environment. Well-developed individual interest has been shown to develop over time through 4 phases, beginning with a triggered situational interest and extending through to well-developed individual interest. Support from other people is particularly important at the earlier stages of interest development, the situational interest, when that interest is more fragile. Situational interest may be a more momentary feeling of curiosity or a desire to continue to engage, but perhaps only if it's easy to do so. On the other hand, those with a well-developed interest will engage with the object of their interest, like a topic in chemistry, independently, voluntarily, frequently, and with knowledge and depth. And so they'll be more persistent and resilient, even in the face of difficulties. So here I situate interest as part of the educational process. It grows, of course, as I've already described, but it also has certain antecedents, that is, things in the environment that will trigger students' interest. And it also has ongoing influences as an interest develop, those things in the environment that help support a person's interest to grow. And interest also has certain consequences and outcomes. Interest matters because it has important educational consequences. It leads to greater students' attention, effort, ability to self-regulate, and higher educational achievement. Being and feeling interested is something that is also valuable in its own right. It's usually, although not always, associated with greater enjoyment of learning. And because we're teachers, interest theory focuses us not just on the individual student, whether they are or are not interested, but rather on the environmental triggers and supports for student interest, things that we can do something about. My own research on this topic started with a growing appreciation of the emotional aspects of learning, that is, valuing interest for its own sake, and as part of building a student's positive emotional engagement with the subject that they're studying. Then I moved on to 3 empirical studies that I'm going to tell you about very, very briefly here that touch on all 3 of these different aspects of the development of interest in the educational environment. So study 1, I wanted to know what triggers students' situational interest during lectures. Lectures have been a ubiquitous feature of higher education for the entire history of the university. Some people have argued that lectures inspire students. If so, I thought, how? How do lectures and lecturers inspire students' interest in new material? So my colleague and I observed 12 first-year undergraduate students in various subjects, including 4 in the sciences, 1 in physics and 1 in forensics, which are included in this larger data set. There were 706 students attending and participating who completed post-lecture surveys in which we asked them what was the most interesting moment in the lecture and why. Then they rated their situational interest in that moment, and they rated various features of the lecture in that moment so that we could see which features or factors were associated with higher situational interest. So we look first at the students' individual characteristics in yellow on the left-hand side, lower left-hand side of this diagram. If students already have an interest in the subject, say physics, in a physics lecture, then they're more likely to be interested also in that particular lecture. So students' level of individual interest is the strongest predictor of their situational interest in that particular moment. But what I want to understand was what teachers can do to make their lectures more engaging. In the blue box, you see a set of features, and those with higher numbers and more asterisks behind them represent larger effect sizes on students' situational interest. Here we see that when students found the lecturer to be enthusiastic, approachable, and friendly, that is, when they had positive perceptions of the teacher, that was associated with greater interest in the lecture. Second, cognitive activation, that is, when students were stimulated to think, they were also more interested. When the information is relevant, important, and useful, that is, having utility value to a student, then that also makes it more interesting. Cognitive incongruity means the information contradicted a student's prior belief or presented something controversial. Novelty is something new. A key message here then is that students are interested when we challenge them to think, especially if there's some kind of novelty in that or some kind of cognitive incongruity. But if it's too hard, then that's negatively associated with situational interest, as shown in red here. That is, they might tune out. So what's the conclusion to this study? How can we trigger students' interest in lectures? First, we can be interesting as a teacher. Second, we can make students think by asking them a question, giving them a puzzle or a problem. We can also show them relevance and usefulness. We can present something incongruent or new, but we always need to remember to pitch that at the right difficulty level. So in study 2, I shifted attention to what happens downstream from interest. What are some of the consequences of having interest in a subject? As you know, employability following higher education is a priority. It's a priority for students as well as universities. And we know that having clear career plans is associated with students' positive career outcomes. So it's important for universities to find ways to support students' career decision-making. The aim of study 2 was to investigate the factors that affect students' career decidedness. In particular, we looked at the relationship between students' interest in their subject, such as physics or chemistry, and their career decidedness. We used a mixed methods cross-sectional study that involved surveying 428 undergraduates. These undergraduates were studying forensic science with a strong chemistry component and also biosciences in a UK university. They were in their first through third years. Most participants had a well-developed interest in science that had motivated their choice of degree program. 70% of students had chosen their program because they were interested in it, as compared to just 37% who chose it for its career utility, and 9% said that they were good at the subject. In terms of individual interests, there were no significant differences across years of study or by program. Most students, or 72% of them, wanted to pursue their interest in the field through their future career, and 44% wanted to pursue graduate study. But fewer than half of them were decided in their careers, and there were no significant differences on career decidedness by year of study or by program, that is, whether they were studying forensic sciences or biosciences. Regression analyses indicated that interest in their subject, biosciences or forensic science, was a significant predictor of students' career decidedness, and that this was mediated by their desire to pursue their interest in their career. Open-ended comments and follow-up interviews revealed how decidedness was informed by students' coursework, their own proactive career exploration, their work experience, and their interest. So in conclusion, we can support students' interest in their subject, whether chemistry or physics or bioscience, to support their career decidedness. This is important because we often talk about employability in relation to skills, but what we see here is that improving their employability is not just about their skills. We also find that most students want to continue to pursue their interest after university, and this gives us something we can focus on, and particularly through the curriculum, because the curriculum matters. We can promote their reflection on their interests and show the career applications and options that are related to the content that we're teaching. Because we've seen that interest in the subject itself may underpin students' exploration of different careers around that subject and their work experience, their clear career plans, and ultimately, we expect then positive career outcomes. So in study 3, we followed up on some of the themes emerging in study 2, building on the idea that interests change and develop over time, and that students' academic and career interests are tightly linked. We shifted from looking directly at students' interest in their subject, that is, on a survey asking them how interested they were in biosciences or in forensic sciences. We instead shifted to having students talk about their career interest. We asked then, how do students' career interests change during UK higher education? For this, we surveyed 663 graduates within 2 months of completing their bachelor's degree. We asked those students who were in a variety of different subjects. So here the focus is not specifically on science. It's looking across different, a comprehensive range of subjects. Did your career interests change during higher education? And then what were your career interests when you started? And what are they now? So we found that 61% of students reported changes in their career interests during higher education. Within those, 27% clarified their interest within a broad standard industrial classification code. 17%, however, made more substantial changes, shifting from one standard industrial classification code to another. 11% simply reported that they were more decided. In other words, they'd had an idea at the beginning of higher education, and that over time they'd become more confident and clearer that that's what they wanted to do. 4% rejected their prior plans and were still unsure what was going to replace that. Then we asked students, what has affected your career interest during higher education? In particular, if your interest or career plans have changed, what aspects of your university experience have influenced those changes? And then we coded their answers. And as you can see, graduates most often cited the curriculum, work-related placements, and work experiences as influencing changes in their career interest. The large percentage of students who rely on their curriculum to shape their career interest is consistent with the findings in study 2. And it's also very telling, particularly in contrast to those who report career services as most central in their career decision-making, which was only 4% of students. This finding again suggests the very important role that academics can play in extracting career learning from academic curricula, making connections between the content of the field and its career applications, and promoting students' reflection on their academic and career interests and how those are linked. Again, I would suggest that taking a broad view of career education within curricula may be most useful. That is, thinking beyond skills to considering how we can help students to develop their career interest. We've seen through this whistle-stop tour of 3 studies that students' interest in the subject matters. In study 2, we showed that it matters to career decidedness, which is important for positive career outcomes from university. In study 3, We've also seen that the curriculum, placements, and work experiences help influence the development of students' career interests. In study 1, we confirmed the importance of 5 key features of lectures in triggering students' interest. In future work, I'd like to better understand the antecedents and other environmental influences on interest in different settings. For example, what stimulates students' interest when working on assignments or in labs? And I'm also particularly interested in intervention studies where some theory-driven element is introduced into the curriculum, such as giving students choice, for instance, and then assessing its impact on interest. With that, I'd like to leave you with this takeaway message. Students' interest matters, and you, as teachers and curriculum designers, have a powerful role to play in supporting students' interest, both in the subject and in their career interests. Thank you very much.